So coming back, this is the different parts of the clutch. The various parts, among various parts, we'll be trying to talk about frictional disc only. Okay. So in the frictional disc, what you are going to find? You are going to find D1, you're going to find D2, you're going to find DM. At the same time, you will be trying to find the force. How much is the amount of force applied? How much force is required for engagement or disengagement of the clutch? So that this force will be transmitted to hydraulic system. So that for the disengagement of the clutch, so much of force will be applied. Based on this force, entire lever or hydraulic system will be designed. Once you are done, this is the H thickness. Now what happens? This thickness is by default, guys. We are not going to design any thickness here. The thickness by default, it is understood that it is 1 to 3 mm. The thickness will be by default will be taken as 1 to 3 mm. So basically in our design we will be trying to take it as 2 mm. Okay, this is what this design which I am trying to talk about. Once you are done with this, there are two conditions always during the design which comes into picture. We call this as uniform pressure theory, and you have something called as uniform wear theory. So two theories which we will be trying to work. Now uniform pressure theory says the entire surface is exactly flat, the clutch surface is exactly flat, and the pressure I am going to apply, the pressure, see, once you have applied a force Fa, the pressure is applied from the flywheel. The pressure is applied from the flywheel on the other side of the clutch. So this pressure applied by the flywheel is very much uniform because the surface is very flat. Now since the surface is flat, when does this surface will be flat? When there is a new clutch. But the used clutches, the surface will not be flat, the surface will be slightly rugged surface. There will be worn out surface. The surface would have been worn out. The friction lining would have been worn out. In such cases, the uniform pressure condition may not be applicable. In such cases, we consider that uniform wear theory, we call this as. So whenever I apply a force Fa, according to uniform wear theory, the maximum pressure will be at the inner side of this. So this will be the maximum pressure, and here there will be minimum pressure, P minimum. So this is how it varies. So same thing on the other side. So this will be the minimum pressure on the other side. So maximum pressure will be the inner surface. Maximum pressure will be having at inner surface and minimum pressure at the outer surface. This is a uniform pressure theory, uniform wear theory. That also we have seen in the last class. Now third important point, we have seen the design procedure. Now the design procedure is very simple. You don't have to break your details. Only there is no procedure. I cannot say that this is a procedure which you need to follow step by step. I'll give you 5 equations. I'll be literally giving you 5 equations where you will be using these equations depending on the situation. Okay. Now 5 equations for this clutch. Now what kind of clutch we are trying to do is we are trying to design, right, at this point of time, plate clutch. Okay. Now this plate clutch is also called as disc clutch. It is also called as disc clutch. Okay. Now this has, once again, there are two types of plate clutches. One is called as single plate clutch and one is called as multiple plate clutch. So both the things are there in your syllabus, single plate clutch as well as multiple plate clutch. Both the things are the same, and the design procedure is almost same. The design procedure, you don't have any, only the difference is here we will be having only one frictional disc, and in case of multiple plate we have many. This takes more space, actually more space is required. So what happens is this single plate clutches are used in cars, buses, heavy trucks, and multiple plate clutches, since you don't have much space, the diameter is less here the diameter of the clutch plate will be less compared to single plate clutch. Since because of this, what happens is I can have a radial distance. Radially I can mount it on a shaft, but the diameter is very small in case of multiple plate clutches. So because of the small in size, we use this in your bikes. Okay, all these motorbikes, all the things we use this. So small vehicles we go for multi-plate clutches. So once again, guys, the design procedure is one of the same, almost same. Okay, I'll be trying to explain it. At this point of time, we have 5 equations. Basically, both the clutches in case of design procedure, we have 5 equations. Let me write all the 5 equations for you. Your first equation is torque equation, guys. Mt is equal to 9.55 into 10 power of 6 capital N by small n. Okay. Now this is the equation which we are going to use it. Now this torque equation. Okay. Now here the unit of the torque will be in Newton mm. The unit of torque will be Newton mm. This power will be in kilowatts. Power will be in kilowatts, and the speed in RPM. The speed will be in RPM. Okay, this is your first equation. Okay, now you have second equation. Now the second equation is to find the diameter. This is to find the diameter. So here you can use this equation. Now eta tau s is equal to mt by z naught, or mt z naught is as equal pi d cube by 16. Else, if you don't want to remember this equation, let me say for example, if you feel that this equation you don't want to remember it, if you are trying to depend directly on the data handbook, instead of this equation, okay, you have the equation directly from your data handbook, equation number 19.49. Equation number 19.49. So what is the equation says? D is equal to, once again you have to see, because both the equations are same. D is equal to cube root of 16 mt divided by pi tau s and eta. This is the equation. So equation number 19.49. So your second step is to find this equation, where this equation will be helping you to find the diameter. Okay. Now what is this eta doing here? Eta is called as QA factor. The value of eta is considered to be 0.75. The value of eta is considered to be 0.75. So this is your second step, which you will be trying to do it. Once you have done this step, your third equation would be the mean diameter. Mean diameter dm. Okay. Now this mean diameter we will be using in two conditions. One is uniform pressure theory and uniform wear theory. So uniform pressure and uniform wear theory, both the theories we will be using. In case of uniform pressure theory, we will be using the equation 19.85a. We will be using the equation from the data handbook 19.85a. I have already shown the equation. Once again, I will try to show in the PPT. Now, if for uniform wear theory, you will be using the equation 19.85b. Let's try to have a data handbook with you so that it will be more comfortable to follow this. Okay, and next one, once you are done with this, so it depends on which theory you are trying to solve the numerator. And next equation is about axial force. Axial force, which you will be trying to work, we call this as FA. Now this is also once again based on uniform pressure theory and uniform wear theory. So here we have once again two equations, equation number 19.86b and you have equation number 19.83. So these are the two theories which we will be trying to use it. Once you have your last fifth equation, your torque, once again the torque transmitted by the clutch. Okay, torque transmitted by the clutch. Now here in this case, the torque transmitted by clutch, we call this as MT. Now you have the equation from equation 19.84 from the data handbook. These are the 5 equations which we will be trying to use it. Now the order, I cannot say that you should be using the same order, but order can be interchanged depending on the situation. Now what happens? Now let me see this. Let me show these equations for you once again. So last class which we have done, these are the equations, guys. So if you observe here, these are the equations which we'll be trying to use it. Okay. So your first equation you have here MT, okay, 9.55 into 10 power of 6 multiplied by capital N by small n, and here shear stress. I have used this formula eta into tau s is equal to mt by z naught, where z naught is equal to pi d cube by 16. Else, as I said just now, we can use the equation 19.49 also. We can use the equation 19.49. Now next one is mean diameter dm. Dm can be used by these two equations. Okay, dm can be used by equations uniform pressure equation or uniform wear equation. So dm you have 2 by 3 d2 cube minus d1 cube by d2 square minus d1 square from equation number 19.85a. Or uniform where you can remember easily d1 plus d2 by 2. Similarly, the axial force from the two equations and torque transmitted by the clutch. Okay. Now for a moment. Try to see here, guys. Okay, in this equation. Now here axial force, you have axial force here. This is axial force and there is one more axial force here. So basically what happens is we assume that these two axial forces are the same. This force and this force are the same. But physically what exactly happens is there is a basic difference. This axial force, what exactly we are trying to talk about in this equation. This is the maximum axial force that can be applied. This is called as the maximum axial force that can be applied. This is what exactly we are trying to talk about. Okay. Now here, this axial force is nothing but the axial force required to get this torque. So this is called as required. Or I can say that actual. Try to understand this. Once again I repeat. So this is a maximum or limiting axial force which we get here. Now in this case it is called as what is required. But initially for a single plate clutch or usually what happens is we basically assume that the maximum is nothing but the required. But physically what happens is this is a maximum I can apply. But to transmit this torque, I can, if I apply, let me say I'll give you in terms of numbers. I can apply the force up to let me say 1000 newtons. I can apply the force up to 1000 newtons. But I would have got a torque of here some value. To run this torque, if I apply 800 newtons also, it will be fine. That is what this difference. So axial force, maximum force is up to 1000. So always this value will be more when I can calculate FPA from here. Now why I am trying to say this, I will be trying to use this concept in multi-plate clutch, not in case of single plate clutches. So once again I am giving you an idea. Try to understand this. The axial force at this point of time, the same axial force, we assume that it both are same. But sometimes when they ask in the numerical saying that try to find the actual one, you have found the maximum one. Sometimes in this some VTU question papers they have asked try to find the maximum axial force. If you want to find the maximum axial force, once you can recalculate FA, but FA to be calculated by using this equation. Do not use this equation to find the actual one. So once again calculate empty everything and use this equation to find the actual or required force. So that is the only basic thing which you need to do. So with this basics, there are a few things which once again you need to understand the concepts. If the material is not given, if the material of the shaft is not given, go with material as steel. Okay, with the shaft, spline shaft is having a is made of C40 steel, carbon steel, with a factor of safety of 3. Okay, now different textbooks use different factor of safety. One textbook talks about 2.5. I am trying to follow basically Shigley design procedures. So our MF spots. This is the two books which I'll be trying to follow it. Okay, design mission elements, design of mission elements by Shigley or MF spots. This is the factor of safety for clutches should be always high because most important transmission element. So once we got this, so sigma shear stress will be sigma normal stress will be 109.53 megapascals and shear stress 0.5 times of sigma will end up to 54.76. This you need to remember, you need to write it whenever the shaft material has not been given. And the keyway factor, do you know it? Now speed is not given. This is rare, very rare. Speed will be given, and if the range of speeds has been given, okay, if the range of speeds has been given, try to select the minimum speed. If there are multiple speeds as given, you need to select the minimum speed because we know that the maximum torque is obtained at minimum speed. And we'll be referring the table number 19.7, table number 19.7 for selecting the friction materials or for selecting the value of mu. Mu is nothing but coefficient of friction, okay, which we'll be trying to use. Can you see that there is a mu here in this equation? So mu in case of torque transmitter, there is a mu here, there is a pressure P here. All these values we'll be trying to take from table number 19.7 based on the friction material. So this is what we have discussed in the last class, guys. With this as the basics, we'll be trying to solve the numericals. Let me start your first numerical, and this is the table which we'll be trying to refer. Now let me start with the first numerical. Try to see this numerical, guys, and we all of us will be parallelly writing the given data. Now let me explain the question to you. A car engine develops a maximum power of 15 kilowatts. So this is capital N. So hope if we are writing the notes, try to make a note of this, because maybe by within next 2 days I may be asking the notes to submit. So once again, capital N 15 kilowatts, let it be in kilowatts only, and it is rotating at 1000 rpm. So N. So one thing, if he has given N and small n, I can easily find empty. That is what he said. The clutch is used is single plate. So the type of clutch is single plate. So when I say single plate, the number of plates I is equal to the number of contact surfaces I is equal to 2. Always remember this. The value of I will be always 2. What is I? The number of friction sites, the number of covers, or I can say that the number of frictional surfaces I is equal to 2 for single plate. Sometimes very rare cases I will be equal to 1. Okay. So the clutch used is single plate of both sides effective, having external diameter 1.25 times the internal diameter. So he is indirectly telling us D2, I have got D2 is equal to 1.25 times of D1, and he has given the coefficient of friction mu, okay, and the maximum axial pressure not to exceed 0.085. So he has given the pressure. What exactly you are supposed to do now? Determine the dimensions. Determine the dimensions. Now, of the frictional surface, especially frictional phase, and the force necessary, the force Fa by default will be finding. The other thing which is most important in the question is uniform pressure condition. What condition he is expecting us to do? We are trying to do by using uniform pressure condition. So let me write the given data for you. So the given data in this case, we will be trying to solve it most easiest way. Okay, we have equations. So let me come with this. Let me write question number 1, which we are trying to solve. Sorry. So can you see my screen, guys?
Yes, sir.
Right. Yeah, thank you. So we are trying to solve question number 1. Okay. So how this question number 1 will be solved here. So Q1. Question number 1 we are trying to solve. What is the given data now? Try to write clearly what is given. Try to write clearly what is given. First, the type of clutch. Mention it. The type of clutch. So the type of clutch is single plate. So always solve the problem by mentioning what kind of clutch is asked and what is this. So the type of clutch, single plate clutch. As a single plate clutch, you mention it, you write it here in the brackets, I is equal to 2. Mention that there is the value of I will be equal to 2. Once you are done, the other data, capital N. So you have capital N in this case, capital N 15 kilowatts is the problem. Capital N 15 kilowatts you have. Now small n, you have 1000 rpm. Yeah. What is that? Any questions? Hello? Are you able to listen to me?
Yes, sir.
Yes, sir.
Right. Yeah. So once again, you have n is equal to 1000 rpm here. Okay, you have the value. Next, once you are done with this, what is the other data he has given? He has given the diameter. He has given the He has given the diameter D2. So D2 is equal to 1.25 times of D1. 1.25 times of D1. What else he has given? He has given that mu. Yes. Mu is equal to 0.3 and pressure P is equal to 0.085 Newton per mm square. and the condition is uniform pressure theory. Uniform pressure theory, right? This is what exactly. Let me start with the design. So design is very simple. First step, go for empty. Empty is equal to 9.55 into 10 power of 6 multiplied by capital N by small n. Multiplied by capital N by small n. So obviously you will be substituting the value of n, in this case is 15. Let it be in kilowatts. He will be substituting the value of small n as 1000. So you will be end up in answer. What will is the answer, guys?
143,250.
143,250. Thank you. Newton. Great. 143,250 Newton. Now once we are done with this, now I'll be going with equation number D. To find the D, I'll write the equation cube root of. There is no point of seeing the data book. It is very simple equation. MT divided by pi tau s eta. Okay. Now if you whenever you take the equation from data book, you mention it equation number 19.49. Mention equation. Now in this case, MT you know, D you know. The problem is this also I can assume as 0.75. This we do not know because he has not mentioned shaft material. So what I can do is I'll try to write it, guys. What I'm trying to write at this point of time, I expect you to write in every problem. Okay, every problem I'll not do it. So we write assume C40 as shaft material. Assume C40 as shaft material with sigma y is equal to 328.6 megapascals and FOS is equal to 3. Therefore sigma is equal to 328.6 divided by 3, which will be around 109.53 megapascals, and tau s is equal to 0.5 times of sigma, which will be 54.76 megapascals. This has to be written every time in the exam because only one problem will be solving in the examination, so you need to do it. So have a habit of writing this. So once you do this, now you will be trying to calculate the value of D. D is equal
26 mm. 26 mm.
26
mm.
Right. You have got this value of D. What we can do is you can round it off to the standard values, guys. You can round this value to the standard values. If you can refer this data and hopefully design 1 you would have studied. What do I try to do is, so the standard value is 30 mm. So from where I got the standard value, you have got this table 14.6 from the chapter shafts. So 30 mm because the standard diameter of the clutch, you can round it off to 30 mm. Now at what particular point of time, if you are not rounding it off also, it is not an issue. Don't worry about that. But it is desirable that you will be rounding off to the standard values, because it is the actual element, guys, which we are trying to design. It is not like something for design. If we are trying to design, the concept should be in such a way that the person should be able to manufacture. That is why we design. So simply for the sake of marks or some calculation, we don't design. So in this case, it is 30 mm, which we call it as. So once you have got this, so your next step would be the mean diameter. Okay, dm. So which theory we are going to use? I have clearly mentioned uniform pressure theory. So according to this uniform pressure theory, I will be writing the equation d2 by 3 d2 cube minus d1 cube divided by d2 square minus d1 square. Now here in this case, you have this, try to write the equation number 19.85a. Equation number 19.85a. Now when we are writing this values, so try to substitute. I know this d2 is equal to, he has mentioned here, d2 is equal to 1.25 d1. So substitute back dm 2 by 3. You have 1.25 d1 cube d1 whole cube minus d1 cube divided by 1.25 d1 whole square minus d1 square. So can you tell me how much will be the value, how many times of d1?
1.13 d1.
Yes, 1.13 d1. Thank you. So I got the value of this one as 1.13 d1. You have got your step number 3. Now step number 4. axial. So, and there is no order once again. You are free to do your order. So, axial force FA, axial force FA, once again by using uniform pressure theory, which we are trying to use it. So you need to remember the equation. 1 or 2 problems you solve, you will remember the equations. So d2 square minus d1 square by 4. Now write the equation number. Equation number is 19.86b. now substitute back here. Fa is equal to pi into p value he has clearly given 0.085 multiplied by d2 square 1.25 d1 square d1 whole square minus d1 square divided by 4. This also you will be getting in terms of d1. How much? How much, guys? Calculate. Try to calculate fast. I will also try to calculate it.
Sir, 0.38.
So
0.38, sir.
0.38 or
38
0.0375. The calculated value which I have got exactly. Is it right?
0.
Correct?
0.03.
Correct, sir.
0.031 square 5 d1 square. Yes or no?
Yes, sir.
Yes, I got this value. This is the values which you have ended up. So your first step is done. Once you are done with your first step, your next step, okay, the last equation is, see, 5 equations you use it. So step number 5. Step number 5, I'm trying to use the equation torque. Once again the torque. Mt is equal to. So torque transmitted by the clutch now this time half. In the first equation was torque transmitted by the shaft. Now torque transmitted by the clutch half mu Fa dm into I. So once again write down the equation number 19.84. You have the equation number 19.84. Once you have got this, you will end up in this one. So what is MT which we have already found? 143250 will be equal to half into mu value he has given. How much he has given the value of mu?
0.75.
Mu, it is not
0.3.
0.3. Coefficient of friction 0.3. 0.3 into, we have got the value of F as 0.0375 d1 square multiplied by 1.13 dm as d1 and I is equal to 2. So you'll end up in finding the value of d1. How much is the d1? Find the d1.
.015 cubes.
No. Tell me the value of
Sir,
d1.
224.19 mm.
224.19
mm.
Right. This is the d1. This is the d1. That's it. Once you got this d1, now you write it. Now 224.19 mm. Then d2 is equal to 1.25 d1, which will be equal to somewhere how much?
280.24.
0.24 mm. You have got value of d2. Then you have got value of dm. Dm is given by 1.13 d1. So 1.13 into 224.19, how much? It is around 253, and you have FA. Yeah, FA is equal to 0.0375 d1 square. FA is equal to 2.031 square. Right, calculated. How much you are ending up?
1884.79.
0.79 newtons. So this is the force which it is required to apply this. Okay, now you got this value of FA. Then obviously you have ended up the thickness h is equal to 2 mm. This is simply take it as h as 2 mm. That's it. This is your problem. Very simple. The numerical is very simple. Okay, so once again I just go through it to try to see here. Okay, now I started with this. Given the type of clutch, single plate clutch, So very simplest way we have solved the numerical. So for solving numericals, you don't have to break your head here. You go with 5 equations. You go with 5 equations, 5 basic equations. Once you are comfortable with this 5 basic equations, you can clearly do it. Okay, you can clearly slowly and start working on. Is it clear? Any questions? Are you comfortable? Anything you would like to ask me, please ask me now, so that we'll go with the other numericals. Anything you want me to repeat?
Okay.
Right. So we'll go ahead and we'll try to solve this. Tilak,
Yes, sir.
any questions, Tilak?
Sir, can you go to the fifth step?
Yeah.
Sir, ಅದು
ಹೇಳಿ.
ಸರ್ MD ಟಾರ್ಕ್ ನಿನ್ನೆ ಬೇರೆದು ಯಾವ್ದು ಹೇಳಿದ್ರಿ ಸರ್ ಅದು?
ಇಲ್ಲಿಂದ ಬಂತಲ್ವಾ MT torque, what is the value?
Yes, sir.
ಬಂತಲ್ವಾ ಇಲ್ಲಿ?
Yes, sir. Yes, sir.
ಎಷ್ಟನಾ?
Yes, sir.
ಇಲ್ಲಿಂದ ಬಂತು. ನಾವು 143250. We have calculated first step. ಅಲ್ಲಿಂದ we have used here.
Okay.
We have used this came from first step.
Yes, sir.
ಸರಿನಾ?
Yes, sir.
Right.
Sir,
Yeah, ಹೇಳಿ ವಾಸ್.
how about H? How do we get H value, sir? 2 mm.
By default, you this value of H is 1 will assume as 1 to 3 mm anything in between. So 1 to 3 mm ಅಂದ್ರೆ by default average value ತಗೊಂಡ್ಬಿಡ್ತೀನಿ. 3 plus 1 by 2. By default take H is equal to mm ಅಷ್ಟೇ. ಬೇರೆ ಏನು ಡಿಸೈನ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಏನಿಲ್ಲ. 2 mm thickness ಇರುತ್ತೆ ಪ್ಲೇಟ್ ಅಷ್ಟೇ. It cannot go for more than 3 mm. Any multi-plate clutch togoli or if you take single plate, it will be between 1 to 3 mm. ಮತ್ತೆ ಬೇರೆ any questions? Any other questions, guys?
ಸರ್ ಇನ್ನೊಂದು ದಪ್ಪ ಬರೀ.
Okay, thank you. I'll write it. Okay, I'll write
Thank you,
it.
sir.
Thank you. And this is what exactly I need. You try to tell me the solution so that both of us will improve. I'll write it larger one. So let us start question number 2.
Sir, how will we know when to take I is equal to 1, sir?
What happens is that fellow will clearly say that only one friction. Let me see, I'll show you here what exactly would have happened. This is basic. See, by default you take I is equal to 2 by default, but when I will be 1, I'll tell you. Usually what happens, there will be a flywheel. There will be a flywheel, and here flywheel is basically made of steel, and there is a clutch plate. There is a clutch plate, and this is the only friction lining we have. This is a friction lining. Okay, now what is happening, if you observe, the friction lining is only on one side, and on the flywheel you don't have any friction lining. You don't have any friction lining in this case. Now in such cases I is equal to 1. But practically what happens is, if you take this I is equal to 1 in this case, here there will be only one effective surface. That fellow will clearly mention the effective surface is equal to only 1. Now here, but usually if you want effective power transmission, one more friction lining, that fellow would have been pasted here. One more friction lining he would have pasted here. So that fellow says both the surfaces are effective. So this clutch will go and engage here. The clutch will go and engage here. In such cases you will be taking I is equal to 2. So by default what you do is, for single plate clutches you try to take the value of I is equal to 2. Okay, and multiple clutches it will be many, that we'll try to solve it later. Okay. But single plate clutch by default you don't worry about this much, because I is equal to 2 should be the right value. What exactly happens is, we design for minimum both the sides are effective, means I have here. Now what is the difference? What happens, the difference is in this equation is only in this equation, the dimensions. If this value is 1, if this value is 1, try to see here now the equation number 5. If this value is 1, you will get half of this diameter. That is the size of the clutch will reduce. That's it. That is the only difference. What happens if you try to do this, the size of the clutch will slightly reduce it. That is what exactly happens. Other than that, nothing will change. So here on the reduction also, because it will be in cubic times, so the reduction also will be, you'll be ending up in trying to take the value of 220 or 219 some value. So here try to take the value of I is always 2 for single plate clutch, because assuming that when I say clutch plate, okay, one side obviously you cannot be effective. The friction lining will be on both the sides. The friction lining will be on both the sides of the clutch. So that is the reason we will be trying to ensure that I is equal to 2 always. Right? Now let me go to the numerical 2, try to see this second numerical. The second numerical, he has given, instead of giving much data, he has given a very simple data. Okay, he has said that design a single plate clutch consisting of contacting surfaces. Okay, now he has given this, yeah, so design a single plate clutch consists of contacting surfaces for a torque capacity of 200 Newton meter. So MT has given now. Due to space limitations, the outside diameter of the clutch is to be 250 mm. Due to space limitations, the outside diameter, he has given only two values. One is the torque and one is the outer diameter T2. Let me solve this. Let us solve this. So once again, question number 2, what he is trying to talk about. So design a clutch. Now he says design a single plate clutch. He is trying to talk about design a single plate clutch. So we will be trying to design single plate clutch. So question number 2, type of clutch, single plate. So type of clutch. So by default, the value of I will be equal to 2. By default, I will be equal to 2. This size will be okay, right? Handwriting.
Yes, sir. Yes, sir.
Yes, sir.
Okay. Now, what else he has given? He has given torque, MT. MT is how much? 200 Newton meter. So convert 200 Newton meter into 200 into 10 power of 3 Newton mm. And what else he has given? He has given the value of D, diameter. Okay, which diameter he has given? Inner or outer? The outside diameter. Yes, D2 250 mm. This is the data what he has given. Okay, now what else we need to assume? What else we need to take is most important is, so he has given this. Now what exactly will be considering? Try to see now. We need so many other values also. Pressure you need, friction material you need. So what we do is, we have first stage assume. Are all the assumptions? What are the different assumptions you are trying to take? One is friction material. If he has not given any friction material, try to take as friction material as leather. The friction material is leather. This is the most commonly used, widely used friction material as leather. Now, once you have got this friction material as leather, now we will be trying to go to the table from table 19.7. Where is this table 19.7 in the data handbook? Now let me show you this table number 19.7. Now try to see on this. Now this is the table 19.7. So we have taken the friction material as leather. Okay. Now which friction? See, coefficient of friction which we are trying to take. It is friction coefficient. Dry friction only will be taken. Always remember this. Single plate clutch will be for dry friction. So dry friction is ranging from 0.3 to 0.5. So let me come back. I'll write here. Dry friction. The mu is equal to 0.3 to 0.5. From where? From this number. So how much will be taking? I'll be taking the average value of 0.4. Average value of 0.4. Now come back. What else we take? Maximum from table number 19.7. The maximum pressure. So once again, pressure, it is ranging from 0.0686 to 0.2746. So once again, pressure I am taking the value. Pressure I am taking 0.0686 to 0.2746 megapascals. I got this. So how much is the average value? Let me calculate. 1746 or 16? 16 na? Correct. 1716 megapascals. Yes or no? So you have got 0.17. So you have got this value. Now once you have got both the values, you have assumed this data once again from where? From the data handbook, table number this one. So once again, please strike 0.1716 MB. Thank you. So you got this value. Next, what is the other assumption we do? The other assumption we do is the shaft material. That obviously the same way what you have done here. The same way assume C40 as shaft material, you need to do the assumption. Most important is this assumption is also very much required. Okay, this assumption is also required. At this point of time, that assumption we will keep it. Let me start with the design now, as usual. Let me start with the design of this. So once again, your first step, your MT. So design procedure step number 1, MT is equal to 9.55 into 10 power of 6 multiplied by capital N by small n, capital N by small n. So you'll be trying to, how much is this value? Yes, not required. Obviously this each step itself is not required. Why? Because he has given, MT is given now. MT is given, so you don't have this step. So come back to this. Second step, D is equal to cube root of 16 MT. D is equal to cube root of 16 MT pi towers eta. Okay, so from this equation number 19.49. Equation number 19.49. So value of eta is 0.75. By taking the assumptions, we will be assuming that tau is 54.76. Okay, 54.76. MT is given 200 into 10 power of 3. Yes or no? So what will be the value of D now?
29.16 mm.
Right. D is equal to 29.167. The standard by default 30 mm.
Sir, 163.
Yeah, 30 mm. From table you should write a standard from output table 14.6. So from where I have taken the standard. Your second step is done. Step number 3. So what should be the step number 3, guys? Step number 3 should be
Mean diameter.
mean diameter. Now step number 3 is mean diameter. Now the question comes, he has not mentioned uniform wear theory or uniform pressure theory. Which theory should I take?
Wear theory.
Great.
I mean,
You should be always uniform wear theory which you are supposed to take. You should not be uniform pressure theory, because uniform pressure theory is applicable only for new clutches. Means when the surface is very much flat. For used clutches, it will be uniform wear theory only. So I go for mean diameter DM for uniform wear theory. Now you need to clearly write it, because examiner needs to know which theory you are going to use according to uniform wear theory. According to uniform wear theory. So once again you will be writing the equation. dm is equal to d2 plus d1 by 2. Very simple equation. d2 plus d1 by 2. I do not know the value of d1. Let it be, so d2 is 250 plus d1 into 1 by 2. Let it be a half. Let it be this equation like this one. That's the equation. And one more thing, when you are writing the equation, mention the equation number 19.85b. Okay. Now step number 4. You have your step number 4. In your step number 4, we will be finding the axial load. Axial load FA. Axial load FA. Once again, this is also according to uniform wear theory. According to uniform wear theory, which will be trying to write it. So equation FA is equal to half pi P D1 multiplied by D2 minus D1. So you have this equation number 19.83. You end up this in equation number 19.83. You have this equation clearly. What is this? It is nothing but your axial load. Once you are done with this, okay, once you have got this, substitute back the values. Now, so here FA is equal to half pi Pressure we have already calculated here, 0.1716, 0.1716 multiplied by D1 multiplied by 250 minus D1. Can you tell me what is the value which we are going to get? So obviously, yes, you will end up with this. Let it be 250 minus D1 as it is. Okay. So let it be this 250 minus D1 as it is. So try to do the calculation part.
0.27.
Yes, 0.27 multiplied by D1. Yes, or no?
D1. Yes, sir.
Yes. So precisely, I'll be getting FA is equal to 0.2695 D1 into 250 minus D1. Yes or no? So you have got this value of FA. So try to see what you have done just now. We have got the value of DM. We got the value of FA. Now the final equation is. The final equation is step number 5 or 4. Once again, torque MT is equal to half mu FA DM I. Okay. Now you have this equation number 19.84. Nothing else. I am playing only with these equations. So MT is given in the numerical. Okay. How much he has given? 200 into 10 power of 3 is equal to half. Mu I have taken from data handbook 0.4. FA 0.2695 D1 into 250 minus D1 multiplied with, okay, DM how much we have got? What is the value of DM we have got? Okay, 1 by 2 250 plus D1. So we have got here. So no, DM is 1 by 2 into 250 plus D1. So we have ended up with this. Multiplied by I is equal to 2. Multiplied by I. So once again, a simple calculation what we try to do in this case. This 2 gets cancelled. And 250 plus D1 and 250 minus D1. A plus B into A minus B whole square formula. Okay. And 2 ones to 0.2. So once again you end up this 200 into 10 power of 3 is equal to, how much is this value? So multiply this 0.2 into 0.2695. So it will be 0.0539 D1 into 250 square minus D1 square. A square minus B square. So once again will be, if you take this inside, you will be having 3368.75 D1 minus 0.0539 D1 cube. I'll end up with the D1 cube now. D1 multiplied by D1 square. So you have D1 cube 200.10 power of into 10 power of 3. Now can you tell me this answer now? So use the calculators. Now here by trial.
213.
How much?
213. 213.
Substitute back 200 into 10 power of 3 na? This one. Are you talking about this? Answer, you're trying to talk about answer?
Yes, sir. D1.
D1, okay. Error method. How much you got when the D1?
213.
213, huh? But I'm getting some other answer.
Sir, 212.155.
Oh, everyone 212.
155.
Okay, everyone also open 212. Okay, 213. 213.15, huh? So 213 or 213 is correct. Fine, maybe. Okay. So this is the answer. Any question? Any other questions? So you got D1. What you see? Any other answers? If you have, try to check it out and let me know the answers. So once you are done with this, now once again you write it as dimensions of the clutch. Dimensions of the clutch. Okay. Now when you are trying to go for this dimensions of the clutch, write what is D1, write what is D1, write what is D2. Okay, D2 has given us 250 by default. D2 has given us 250. This is 213 mm. Okay, 213 mm. Then you try to calculate the value of dm. You try to calculate the value of dm. dm is half 250 plus d1. How much? Tell me the value, man. And you calculate the value of fa 0.2695 d1 into 250 minus d1. How much is the value? Let me know. And h is equal to 2.
Sir, DM is 231.07.
Okay. FA. FA.
Sir, 2123.9.
2123.929
929.
newtons. Right. This is your numerical. So you will end up in finding these values. Okay. This is the force required. So any questions now? Are you comfortable with this procedures? So come back. This is your question number 2, which you have solved. Now come back to this. Listeners, we will be having by default of today, even at 3 o'clock, I'll be taking it because I thought of completing single plate clutches today. Let's see what I can do is I can try clearly show the everything I can type in PPT and show it, but you will not get the feeling of learning or feeling of practicing. So I'm allowing it. What you do is I want you to solve question number 4. So I want you to solve question number 4 now. All of us here, just go through it. Take the question, take the screenshot of this question number 4. At 3 o'clock, I want you to tell me the answers. See, the question number 4 is what he says in question number 4. Design a single plate clutch consisting of, question number 4 now. Yeah. Design a single plate clutch used in automobile transmission for the following specifications. Power he has given, capital N he has given, and he has given the speed. He has given the speed 1500 rpm to 2500 rpm. Which speed should I take, man?
1500.
Minimum speed. Maximum.
Yeah, minimum speed. It is not the average. You are supposed to take the minimum speed, 1500 rpm. So take 1500 rpm, solve the numerical. So now here the friction material is molded asbestos on steel. Now what you do is take the screenshot of this. If required, if you do not have data handbook, this is volume 1. I hope everyone should have this volume 1 data handbook. So chapter number 19, volume 1. So this is the table. From this table, take the value of let me share it properly. Yeah. Now here, if you can observe it, I have highlighted here the volume of dry friction of molded asbestos 0.2 to 0.5. So the average will be 0.35 for mu, and maximum pressure, you take this screenshot also if you do not have data handbook, 0.34522 to 1.0346. So use these two values, and keep your solution ready by 3 p.m. today. Okay, whatever the subjects, we have a class by 3 p.m. today by default. So I'll be trying to talk about this numericals, and I'll be trying to introduce multi-plate clutches today itself. We will be introducing multi-plate clutches, so do not miss my class. Any other questions you can ask me now.